All right, I'm going to apologize ahead of time if you hear me coughing. Sorry about that. Bit of a cold right now going on, so I'll try not to cough as best I can, but let me just apologize ahead of time. Okay, this is Algebra 1, Lesson 8.1, and we're dealing with products and powers of exponents. As you know, ever since pre-algebra, we've had a rule section on all of our tests, and it is really important that you are very capable concerning all of the rules. Well, this chapter reviews all of the exponent rules and such, and so it's really important that by the time we finish this chapter, you really have them down so that they'll no longer be an issue when you get to Algebra 2. Okay, so Algebra 1, Products and Powers of Exponents, Lesson 8.1. All right, let's open up this way. So we're going to start with the product property. The product property. Now we've had the basic form already. This is a little bit more intricate of a form. It's got coefficients. So the C here is a coefficient. It might be a 3. And the D here is a coefficient. It might be a 2. So it'd be something like 3x to the A times 2x to the B. All right, so the C and D are coefficients. Well, you're multiplying, right? That's what the raised dot says. So it's going to be coefficient times coefficient, C times D. And then you're going to apply the exponent rule, x to the, do you remember the rule? And you should say, you add the exponents, x to the A plus B. Remember, all this is a shortcut. This is just a shortcut. That's all there is there, and I'll try to remind you of that here as we go along. Okay, so coefficient times coefficient, and then the way to multiply like bases, notice these are both x's, right? The bases are x. You simply add the exponents. It tells you how many of them you have. So let's take a look at some examples here. A. All right, so I kept the color to make life easier in the first problem. So we're going to multiply the negative 3 times the 5, right? We can all do that. Negative 3 times 5 is a negative 15. And then again, with our exponents, and I'll show the rule step, you have an n cubed times an n to the 6th. Just a reminder, what is an n cubed? N times n, right? There's 3 n's. What's an n to the 6th? 6 n's multiplied together, right? So that's 6, 1, 2, 3, 4, 5, 6. I got an extra one there. Oh, great. Got rid of them all. Let's use our eraser here. Okay, there we go. So n cubed times n to the 6th. So that when you apply this rule, it just saves you from all of that thought, and you're simply going to add the exponents because that allows you to figure out how many n's there are. So again, watch. 1, 2, 3, 4, 5, 6, 7, 8. There are 9 n's, right? N times itself, 9 times. So where do we end up with? Negative 15 n to the 9th. Okay, so again, the rule is a shortcut to keep you from writing out all the variables. All right. All right, second example here. In this one, we've got we got a fraction involved. Well, don't let the fraction scare you. It's still coefficient times coefficient. And if you remember way back, I told you, look, just put the 6 over 1. It'll keep things straight. We'll deal with that in a moment. Let's deal with our variables. We got an x. I'm going to write them all first, and then I'll do the exponents just for color's sake. So x, y, z in black here. And then the x2 plus, what's the exponent over here on the right? What's the value of the x's exponent? And I hope you'll say 1, right? It's not shown, but it's 1, right? We just don't write the 1. So don't neglect that. You got to have that there. All right, we have y cubed, and there are no other y's, so that just stays y cubed. We have z to the 4th plus, and notice the z's exponent, z to a negative 2. Okay, so let's go step by step. First off, look right here, coefficient times coefficient. All right, when you see two fractions being multiplied, you think top times top, bottom times bottom, and you think R-bum, right? Reduce before you multiply. Otherwise, you're going to make more work for yourself. So again, 6, 2 times 3, and 8, 2 times 4, and the 2's divide out. Okay, where do our coefficients end up with? 3 times 3 is 9. Over a 4, we get 9/4. How many x's? X cubed. How many y's? Y cubed. How many z's? Positive 4 and a negative 2 leaves you 2. So it looks like 9/4 x cubed, y cubed, z squared. Look, just take it one step at a time, one piece at a time, and if you'll do that, you should end up and be where you need to be. One piece at a time, one step at a time. Let's do another one. All right, so how about this one? So here we have three things being multiplied together. Okay, well, don't let that throw you. Here's term number one, term number two, and or factor number three, right? So we have three factors being multiplied together. And look, we're still going to do the same thing. Coefficient times coefficient times coefficient. So negative 3 times 4 is a negative 12, and a negative 12 times a positive 7. If you don't know how to do that in your head, use your calculator. It's a negative 84. Now look, here's really how we should start doing the exponents. Once you got the rule down, you understand it. This is how easy these go. So watch my A's. I'm going to circle them. You don't need to in your notes, but I'm going to do that. I have a squared, two of them. A to the first, that gives me a cubed. A to the first again, that gives me a to the fourth, right? It's a to the 2 plus 1 plus 1, a to the fourth. Okay, should have erased before I did this, so let me just get rid of that. Just want to get rid of my circles there. Okay, and I'm going to do the exact same thing with all the rest of my exponents. All right, I got b, right? This b is b to the first, right? Though it's not shown. Plus b cubed, that's b to the fourth, plus b to the first is b to the fifth, right? And then look for c's. No c's in the first term, c squared in the second, c to the first and the third, c cubed, and that's it. Negative 84, a to the fourth, b to the fifth, that's a b, ugly b. C cubed's even uglier now, isn't it? Oh well, it's all right. It's what happens when you write on an electronic pad. All right, so negative 84, a to the fourth, b to the fifth, c cubed. All right, let's go to the next property. The next property is the power property. Power property. Everybody likes power. And you should have, I think most of you guys remember this property. You usually don't get this wrong on your tests. So what's the rule? X to the A to the B equals X to the A. And yeah, hopefully you're saying times B. X to the A times B. You multiply the exponents. Again, this is a shortcut that allows you to do the problem more quickly. What is the key to a problem like this? The key to most situations involving bases and exponents is understanding what is the base. Please understand that this B only applies to the base. The base is what's in parentheses. If you'll only apply it to the base, you'll be in good shape. All right, let's look at some examples. All right, so A is very simplistic, right? You're going to end up with n to the 3 times, oops, yellow. I want it red. N to the 3 times 5, right? And we all know that that is n to the 15th. Now look at B. I spaced it out a little bit so you can get a full appreciation for what's going on here. Oh, let me go back to A for a moment. So let me remind you what this is really doing. All right, we did this. Ooh, let me hit my undo button. Come on. Okay, so remember we did this in pre-algebra, and I'm just going to refresh your memory. An n cubed to the fifth power would technically be n cubed times n cubed times n cubed times n cubed times n cubed, right? 1, 2, 3, 4, 5 of them. And remember, each n cubed is n times n times n. So really, what do you have? You end up with n times itself 15 times. What's the rule doing? It's just a shortcut for all of that. 3 plus 3 is 6, plus 3 is 9, plus 3 is 12, plus 3 is 15, and the 15th, but we can do a shortcut. We can just multiply them, right? That's what's going on. Okay, let's look at B. All right, so be careful here. Each factor inside the parentheses has to get this 3 applied to it. Okay? You have to apply this 3 to every exponent of every factor in the parentheses. Now, what's the exponent of the 2? I hope you're thinking 1. It's not shown, is it? I'll write it in because it's more clear when we write it in. And what's the exponent of the a? It's also a 1, though not shown. So look how this rule ends up. Look what happens here. 2, I'm going to my red, to the 1 times my green 3, right? Isn't it x, watch, to the a times the b, right? And you got to do this for every term, every factor here. A, its exponent 1 times the b value, in this case 3. And then you got to do it with the b. Its exponent 2 times the b value, the 3, and that's where you're at right now. All right, be careful with the coefficient. We really don't want to leave that in exponent form. Now, variables, we have no choice, right? An n to the 15th, looking back here, right? An n to the 15th is an n to the 15th. You can't do anything with that. But in our box right here, this is a 2 cubed. And we all know what 2 cubed is. 2 times 2 times 2. 2 times 2 is 4, times 2 is 8. And you should leave that as an 8, not as a 2 cubed. We want simplified form. All right, how many a's? 1 times 3 is 3. How many b's? 2 times 3 is 6. 8 a cubed b to the 6th. All right, let's do a few more problems of this nature. All right, look at C here. All right, remember in the beginning when I said make sure you only apply the exponent to its base? All right, so watch. Look at C. See this 3 exponent? Please understand it only applies to its base right there. How did I know that's the base? The parentheses. That's why the parentheses is there. So we only apply it to its base. So really you have a negative 3 and it's just sitting there. And now we're going to start dealing with this exponent. So I have the x, its exponent, times the b value 3. Y, whoops, let's get rid of purple. Y, its exponent, 5, times the b value 3. So look where we end up on this one. The negative 3 is just by itself. X to the 2 times 3 is x to the 6th. Y to the 5 times 3 is y to the 15th. And that's that one. Only apply the exponent to its base. Now our last example of this type is a little bit different here. We got a 2/3 a b cubed, the whole quantity squared. Now everything's in the parentheses. So again, let's take a look. What is the exponent of the 2/3? It's a 1. What's the exponent of the a? It's a 1. So watch where we're at. 2/3 to the 1 times 2. A to the 1 times 2. B to the 3 times 2. What's a 2/3 squared? Well, you can think of it 2 different ways. Most like to do 2 squared over 3 squared. Over to the left here, it's the same thing as what? What's a 2/3 squared? A 2/3 times a 2/3, right? See, 2 squared over 3 squared. Okay, but you can think of it either way. Okay, and now do the a. 1 times 2 is 2, so that's a squared. Do the b. 3 times 2 is 6. And again, we can simplify that, right? So simplify the coefficients here. That's a 4/9. 2 squared is 4. 2 times 2 is 4. 3 times 3 is 9, right? A squared, b to the 6th. Final simplified answer. 4/9. A squared, b to the 4th. Okay? So 2 rules today. We've got a little bit more to do, so don't think this is over. I just want to recap. Again, the first rule, when multiplying like bases, multiply coefficients, and then the bases, you add the exponents of the like base. What do you do with an exponent to an exponent? You multiply the exponents. All right, let's take a look at the Second page here of your notes. All right, so compound problems. Compound, meaning you got a little bit more involved. All right, key, as always, in all math is follow the order of operations. Follow the order of operations. You got to follow the order of operations. Do that, and life becomes simplistic. Now, they look a little intimidating, but just follow procedures. So what's the order of operations? Are you running through it in your brain? All right, let me refresh your memory, right? It's evaluate all exponents, then multiplication and division left to right, addition and subtraction left to right. Right here, we have an exponent problem, and we've got to deal with this 3 exponent to its base. We've got to do that part first, okay? You might say, well, what about the x squared? You can do nothing more with the x squared. It's just simply an x squared. An x squared is an x times x. But whenever you have a parentheses to an exponent, you can use the power rule to simplify that. Okay, so that's what we have to deal with first. So we got our negative 3 x squared y. And now let's deal with the parentheses. I'm going to do these in blue just so they stand out. 2, its exponent times the 3. X, its exponent times the 3. Y, its exponent times the 3, right? All right, so look where we're at. Still got the black part, negative 3 x squared y. Do you agree? Again, if ever I'm going too fast for you, you just pause the video, catch up, and then you're ready to follow along. All right, so remember, here again, we got a 2 cubed. 2 times 2 is 4 times 2 is 8, right? That's an 8. X to the 2 times 3, x to the 6th, y to the 3 times 3, y to the 9th. Now we're ready to finish. So how do you finish this? Coefficient times coefficient. Negative 3 times 8, negative 24. All right? Like basis times like basis. X to the 2 plus 6, x to the 8th. Y to the 1 plus 9, y, not x. Y to the 10th. Right? Did you catch that? No Kool-Aid for you? All right, negative 24, x to the 8th, y to the 10th. All right, a similar problem here with b, right? Similar. Again, we got to deal with this exponent in its base first off. Whoa, let's go back. Okay, so as we take a look at this, we'll get there. All right, so as we take a look at this, we still have the n cubed. And now let's start dealing with the exponent. So first thing I have is n to the 2 times 5, p to the 4 times 5, right? Do you agree? And so where do I end up with? N cubed times n to the 10th times p to the 20th. And now I'm ready to do the like bases. N cubed times n to the 10th is what? What do you get when you multiply those together? And hopefully you say n to the 3 plus 10 or n to the 13th times p to the 20th. And away you go. That's it. Right? That's all you're going to do there. All right, a few more problems here. All right, number 4. Watch out for addition. Beware of addition. Remember, multiplication rules and addition rules are different. Don't forget, only like terms can be added, right? Be careful, be careful, be careful. That negative right there between those two terms changes it from addition to multiplication. So that's a difference there. Okay, I'm back. Had an interruption there in the hall, so I had to take care of that. Okay, so we're looking at problem A here. Notice the negative sign. It means we have two quantities. We've got one here and one here. And so at best, maybe we can add them up, but we have to follow the order of operations first. And we're going to deal with this exponent right here, right? That we can do. The other term's already done. Well, to a degree. There's also a part we can do to it. All right, so let's deal with the exponent first. This negative sign, I have 2 to the 1 times 2, n to the 2 times 2, p to the 3 times 2. All right, that's going to take care of this right side term. Now, because I'm dealing with that exponent, I can also deal with the left side term. Notice right here, what's n squared times n squared? And hopefully you think n to the 4th, right? Okay, so that's where I'm at right now. All right, let's write the next line. We still have a 2, n to the 4th, p to the 6th, minus, what's a 2 squared? And you should think 4. N to the 2 times 2, n to the 4th, p to the 3 times 2, p to the 6th. Look where we're at right now. We have like terms. Right? And from day one, this is what I tried to teach you. 2 of them, positive 2 of them, and a negative 4 of them gives you what? A negative 2 of them. And what are the thems? An n to the 4th, p to the 6th, right? A negative 2 of the like terms. 2 apples minus 8 apples, negative, or minus 4 apples, negative 2 apples, right? It's 2 of them minus 4 of them leaves you a negative 2 of them. All right, I got one more problem here. One more problem. Pink. Yuck. How do we get pink down there? It's ugly. Let's get to white. All right. Got a pink border. Who cares? All right. So let's take a look at problem B here, the last problem. And in this problem, you can see we have something to distribute, right? We've got a negative 2xy squared in front of a parentheses. That operation is multiplication. And we're going to need to multiply it times the 3x and times the negative 5y. So let's do that first. Okay, negative 2 times a positive 3 is a negative 6. An x times an x is an x squared. And then you still have times the y squared. And that was the first distribution. It's what we get when we do the first distribution. I'm going to do the second distribution in blue. Negative 2 times a negative 5 is a positive 10. You have the x, there's no other x's, so x. And here we have y squared times y is y cubed. And that's the second distribution. All right? Did you follow? Negative 2 times negative 5, positive 10. The x, there's no other x to multiply it times, and then y squared times y is y cubed. And we still have plus, keep grabbing the wrong pen because my orientation is off, plus the x squared y right there, right? Y squared. Okay, do you see any like terms? I do. I have a negative 6 of them and a positive 1 of them, right? 6 negatives and 5 and 1 positive leaves you 5 negatives. Negative 5 x squared y squared. And still plus the 10 xy cubed. Now we're not multiplying, we're adding, so there's nothing further we can do. It stays just like that. All right, be careful in this type of problem. Don't mix up multiplication and addition. Watch out for addition. Only like terms can be added. Those are a little bit trickier, and you just got to pay attention to detail, and you'll be okay. All right, that's the lesson. I hope you do well with it.